mode, the mode, mean, median, the mode. Come on, everybody, so here we go. The 3 M's that you really need to know. The mean, median, the mode. So, mean, median, the mode. Everybody, come on, so here we go. The 3 M's that you really need to know. Mean, median, the mode. The mean, the mean. Come on, kids, really.
Hey guys, and welcome to the Kearney Math Show. Thank you all for tuning in to the Kearney Math Show. Today, on today's episode, we are going to be featuring mini lesson 2 in Unit 10, box and whisker plots. So before we get started, go ahead and write at the top of your mini lesson entry number 2. And go ahead and read your learning goal. So our learning goal is that by the end of today, I want you guys to be able to explain to someone else how to either create a box and whisker plot, and more specifically, I want you to be able to, even if you can't create one, I want you to be able to look at one and know how to interpret it. Okay, so that's our big thing, is being able to interpret a box and whisker plot. So we are going to actually skip the top part of your mini lesson up here, and we're going to go directly to the notes section, and we're going to come back and do that top part later. So when you look at this, when you look at the notes, when you hear the word box and whisker, what do you hear? Box and a whisker. So that's exactly what it is. It's a graph that has a box and some whiskers coming out to the side. And a box and whisker plot, so again today I'm just going to be clicking, and you can write what I'm clicking on the board, okay? So a box and whisker plot is a graph that represents information from a 5-number summary. How many numbers? 5, okay? And we're going to talk about what those 5 numbers are. That means you can take a data set that's got 1,000 numbers in it, and you're going to find 5 very important numbers in that data set to create a box and whisker plot. Okay, so box and whisker plot helps to simplify big data sets. So if you've got a data set that's got a lot of numbers, this is going to help you to simplify that. Okay, it's also really, really good because when you visualize what a box and whisker plot is, it also helps you to determine if there are outliers. Do y'all remember that word outlier from yesterday? What do we say an outlier was? Right here, this word outlier. What do we say that was? It was a number that didn't belong. It's a number that is either way bigger or way smaller than the other numbers in a set. So if all the numbers are in like the 80s and 90s, and then there's one number in the 20 range, then that is an outlier. Okay, and box and whisker plots are always really good, are also really good to compare 2 or more data sets because they're very visual. A box and whisker plot helps you to visualize just how spread out a data set is. Okay, so down here you have a example of a box and whisker plot. So if you look, I have this box, and then I have a whisker out to the left and a whisker out to the right. And if you look, there are 5 important things. Remember I said earlier how many? It's a 5-number summary. So we've got 5 numbers here, 2, 3, 4, and 5. That doesn't mean there are only 5 numbers in the data set. That means we're going to take the data set and pull these 5 numbers out from it, okay? So let's talk about what those 5 numbers are. The first one is usually you're going to take your data set and you're going to find the median. But before you can find the median, what do you need to find? What do you need to do with the data? You're going to put it in order from least to greatest. Okay, so the very first thing, you're going to put your data in order least to greatest and find the median. And what do we say the median was? The median is the middle number. Okay, so now that you've got your data in order, least to greatest, and we found the middle number, can you visualize that you now have separated your data into 2 equal parts? Okay, we've got the upper half above the median and the lower half below the median. Okay, so let's talk about what this lower extreme is here. The lower extreme is exactly what it sounds like. If you've got an extreme, it's way out there. So the lower extreme is the smallest number in your data set. So you look and you find the smallest number. So we've got our median's the middle number. The lower extreme is the lowest number. What do you think up here, this upper extreme is? What do you think the upper extreme? It's the largest number. Okay, so the lower extreme is the lowest number, the upper extreme is the biggest number. So once you find your median, you have your, like I said earlier, you have your data separated into two equal parts. And so what we're going to do, this lower quartile, that is actually the median of the lower half of the data. So we're going to separate the data into two equal parts, and then we can find the median of the lower half of the data. So the lower quartile is the median of the smaller half of numbers. So if we put our numbers in order least to greatest, we find the middle number, then we go over to the left side and we find the median of that lower half. So that's the lower quartile. If that's the lower quartile, what do you think the upper quartile is? The upper quartile is the median of the upper half of numbers. Okay, so that means if we're looking and we've split our data into two equal parts, we're going to find the median of the upper half of the numbers. Okay, so the 5-number summary that I've given you. 1 is the lower extreme, that's the smallest number. Next is the upper extreme, which is the largest number. Then the median is the middle number after the numbers are in order. And then you have your lower quartile, which is the median of the smaller half, the upper quartile, which is the median of the upper half. Okay, so those are our 5 things, and we'll talk more about those when you come to my station. So how many numbers do you need for a box and whisker? 5. Okay, so now if we're looking over at the right-hand side, what did we say separates the data into two equal parts? When you separate in the middle, that's the median. Okay, so I want you to picture with me. We have taken a data set and we've separated it into two equal parts. So if we come back over here, we look down here, the median separates into two equal parts. So we've got our lower half, which is here. And then I've got my upper half, which is here. Okay, so then what do you notice that the quartiles do with the lower half? It separates it, and then the upper quartile separates it. So now, when you hear the word quartile, what do you hear? Quarter. So how many parts do you think when you've got your median and your quartiles, how many parts now do we have in our data set? 4 equal parts. Okay, so we've got, if we look back at our picture, we've got 4 equal parts. So let me draw in another color. So we've got this part over here, 1, 2, 3, and 4. Okay, so your quartile has separated into 4 equal parts. So we've got the median separates it into 2 equal parts, quartile 4 equal parts. So if you've got all of your data, you have all of it. What percentage do you have? You have 100%. Okay, so now we've taken 100% of the data and we've separated it into 4 equal parts. So what would 100% separated into 4 equal parts be? 25%. So each little quartile represents 25% of the data set. So each quartile, that's important. We're going to talk about that when you come to my station. Please know that. Each quartile represents 25%. Okay, next, we're going to talk about the interquartile range. So basically, what did we say yesterday the range was? The range was the highest number minus the lowest number. So what do you think the interquartile range is? Okay, so the interquartile range, which is also, some people say the IQR, is exactly what it sounds like. Just like the range is the highest number minus the lowest number, the interquartile range is the difference between the upper quartile and the lower quartile. So it finds the range between the two quartiles. Now, if we said that each quartile represents 25%, we said that, right? So the interquartile range represents 50% of the data. That's really important, which is 1/2 as a fraction. Okay, and the interquartile range, if you don't know what the interquartile range is, basically, guys, it just spans the length of the box. So when you're looking at your picture and it says, what is the interquartile range? Just figure out how big your box is. So inner quartile range is the measurement of the box. So if I look back at this picture, let me erase all my scribble here. Okay, if I look at my box to find the inner quartile range, I can look and say the upper quartile is at 17, the lower quartile is at 10. So what's the length of my box? 7. So my inner quartile range would be 7. Okay, so I know, guys, that was a lot of information, and I promise you when you come to my station, it's going to make a lot more sense. But what really important things I want you to make sure you know when you come to my station. I want you to know what 5 numbers you need for the box and whisker plot, and I want you to know what percentage each part of that box and whisker plot represents when you come to my station, which we said was 25%. All right, guys, so go back right now and rewatch the video if you need to, and if you feel like you know it, then you can go ahead and try to start example 1, where you're creating your own box and whisker plot based off the math test scores. And that's where we're going to pick up when you come to my station. Okay? So good luck, guys. Peace out, rainbow trout. Love you, mean it.